Okay, now we are going to look at another style of a delta Y connection. In the problem we have two loads that are connected to the same three-phase supply. One is three 15 ohm resistors connected in Y, drawing a line current of 30 amps. The second load is three resistors where each of them are the same value, connected in delta, drawing a line current of 20 amps. Find the value of the resistance in each phase of the delta connection. And again, the drawing is important for this, so to start with, pause this video and draw what you think this load would look like. Okay. The drawing you did should look something like this. What we have this time are two separate loads connected to the same three-phase supply. One's Y connected and one is delta connected, but they are both connected to the same supply. And what we are looking for is the value of resistance in each phase of this delta connection. So what we know for the delta is the line current that this delta load draws. Because it's a balanced delta load, the three resistors are of equal value, so the same resistance in each phase, same power factor in each phase. We can use the rules for balanced delta systems. And if I want to know the phase current on each phase of this delta load, I would simply go I phase equals I line divided by root 3. Which equals 20 amps divided by root 3, and that is 11.55 amps per phase. So I know the phase current for this delta load is 11.55 amps. What we want to find is the resistance of each resistor in delta. And the problem is I don't have a voltage. If I knew what the phase voltage was, I know what the phase current is, and I could find the resistance in each phase. But I don't know anything about the voltage feeding this delta load. However, I do know there's a Y load connected to this same supply, and I should be given enough information for the Y load to help me figure out what the voltage is feeding the Y load. Whatever that voltage is feeding this Y load will be the same system voltage that's feeding the delta load. So I'm going to use the Y load to find my system voltage. If the resistor in each phase of the Y load is 15 ohms and the line current for the Y load is 30 amps, one thing we know about current in a balanced Y is that I line equals I phase. Which is going to equal 30 amps. So the phase current in each phase here is 30 amps. To find, if I know the phase resistance and the phase current, I can find the phase voltage. V phase for this load is going to be I times R. 30 amps times 15 ohms will equal a phase voltage of 450 volts. Okay, if the phase voltage is 450 volts, we can find the line voltage feeding this Y system, and that line voltage will be the same voltage that feeds the delta system. In a balanced Y load, V line equals V phase times root 3. And 450 times root 3 equals 779.4 volts. So this three-phase supply has a line voltage of 779.4 0.4 volts. If that is the line voltage that feeds my delta load, now I can find the phase voltage on each phase of this delta load. In delta, V line, or V phase equals V line, which equals 779.4 volts. Now I know the phase voltage for each phase, and I know the phase current for each phase. So to find the resistance of each phase, R phase equals V phase over current of each phase, R equals E over I, which is 779.4 volts divided by 11.55 amps, and gives us a resistance in each phase of 67.5 ohms. So the value of resistance in each phase of the delta connection is 67.5 ohms. This is the second style of question you could see for a Y delta connection. And again, the biggest part is just to be clear about how it's drawn. If it's two separate loads connected to the same supply, just draw the two separate loads connected to a single supply and use the values you have and the rules for Y and delta to find the answer you're looking for. That's pretty much it.